Hello friends, I welcome you in my YouTube channel. Today in this video I am going to talk about effect of acidity and basicity and pH on enzymes, and I hope this versatile topic will be beneficial for you. So let us to start today our topic pH, acidity and basicity of enzyme. Friends, you know H plus and OH minus ions are charged and therefore interfere with the hydrogen and ionic bonds that hold together an enzyme, since they will be attracted or repelled by the charge created by the bond. This interference causes a change in shape of enzyme and importantly its active site. Different enzymes have different optimum pH values. This is the pH value at which the bond within them are influenced by H plus and OH minus ions in such a way that the shape of their active site is the most complementary to the shape of their substrate. At the optimum pH, the rate of reaction is at an optimum. Any change in pH above or below the optimum will quickly cause a decrease in the rate of reaction, since the more of the enzyme molecules will have active sites whose shapes are not, or at least are less, complementary to the shape of their substrates. Now friend, small changes in pH above or below the optimum do not cause a permanent change to the enzyme, since the bonds can be reformed. However, extreme change in pH can cause enzyme to denature and permanently lose their functions. Enzymes in different locations have different optimum pH values, since their environmental conditions may be different. For example, the enzyme pepsin functions best at around pH 2 and is found in the stomach, which contains hydrochloric acid. So you can see the rate of enzyme activity at optimum pH. Changing the enzymes in substrate concentration affect the rate of reactions of enzyme catalyzed reactions. Controlling these factors in a cell is one way that an organism regulates the enzyme activity and so its metabolism. Changing the concentration of substrate only affects the rate of reactions if it is the limiting factor. That is, it's the factor that is stopping reactions from proceeding at a higher rate. Friend, if it is the limiting factor, increasing concentrations will increase the rate of reactions up to a point, after which any increase will not affect the rate of reactions, and this is because it will no longer be the limiting factors and another factor will be limiting the maximum rate of reactions. As the reactions proceeds, the rate of reaction will decrease, since the substrates will get used up. The highest rate of reactions, known as the initial reaction rate, is the maximum reactions rate for an enzyme in an experimental situations. Friends, increasing substrate concentration increases the rate of reactions, and this is because more substrate molecules will be colliding with enzyme molecules, so more product will be formed. However, after a certain concentrations, any increases will have no effect on the rate of reaction, since the substrate concentration will no longer be the limiting factor. So enzymes will effectively become saturated and will be working at their maximum possible rate. You can see here our rate of reactions and substrates concentrations. Now friends, you can see increasing enzymes concentration will increase the rate of reactions, as the more enzymes will be colliding with the substrate molecules. However, these two will only have an effect up to the certain concentration, where the enzyme concentration is no longer limiting factor. So friends, I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.